Hi, so this is my geometry journal number 5, and I wanted to experiment a little bit more with GeoGebra. I came across this article, Developing Geometric Thinking Through Activities That Begin with Play, by Pierre Van Healy. So I thought it would be appropriate for some of the discussion that we've been having on reaching students at all different Van Healy levels within a topic. So this article in the beginning is talking, it recaps a lot of the different Van Healy levels and then also the learning levels. And then it goes into discussion about this mosaic puzzle. And the suggestion is to take this template and print it on cardstock in different colors, I guess, for students to use, or numbered. I went over to Geogebra and just typed in mosaic puzzle, and I saved it to my workbook in case I wanted to use it in the future. And so I, just to double check, I came through and recreated this puzzle to make sure that all the parts were the same. And as you can see, this mosaic puzzle here matches the one in the article. So the beginning of the article talks about having this puzzle and letting kids just explore different things with it, create different shapes. We're at that beginning level with visualization. And then we move on to having a task card asking kids, and these are the learning steps here. So after letting kids explore, the next step is going to be to give them a little bit more structure, a task to complete. And so this task card is asking students to use 2 puzzle pieces to create this house shape here. And so if we start out here, then I'm going to take these 2 pieces and create my house shape. And the next task is, so when I'm doing this, I'm looking here at some possibilities. I'm talking about how these 2 sides match up. And with the grid that we have here, makes it very easy, I'm noticing, to talk about area as well. Like if we start with the smallest shape here, then the area of this triangle is going to be 1, 2, 3, 4 if we're counting our units as the small triangles on the grid. And so if I'm looking at the length of this rectangle, I've got 1, 2, 3, 4 lengths, and that's going to match the bottom of this triangle. The next task is asking me to use with 2 different pieces to make this, create the same house shape. And so this I struggled with a bit, and then I found that I wanted to layer. So if I'm having to use 2 different pieces, then I'm going to take this piece and see if it matches up, since I can try different shapes. I can do this, but that's going to require 3 pieces. And then this one's a little odd. I can move things around. They won't change the shape, they just rotate. But I can't get that to fit in there, so then I tried this one and that fits. So those are 2 different houses with different shapes. And if we're wanting to extend and move on maybe to starting to use some formal language, then we can talk about the names of these shapes: rectangle, triangle, quadrilateral, trapezoid, and so on, and explore some of the attributes of these shapes. The next part of the activity is asking us to use this triangle here and one other piece to create a tall house So I'm going to use this piece. And then it asks for us to use these two pieces to create the same shape. So there we go. And then it's asking if it can be made with 3 pieces. So here, students might begin to notice that 2 of the pieces that we have will make the same shape as another one. For instance, these 2 pieces can be a substitute for the brown one, and then I've used 3 pieces to make the tall house. And then the next activity, it goes into students creating their own shape and creating an outline of it to give to somebody else to recreate and to make their own puzzles. I think this is a great way for kids to just play around with different shapes and incorporate some of the vocabulary that comes with discovering these shapes, sides and angles, and as they get older, more complicated vocabulary. Another thing the article talks about is enlargement, and it's based on this triangle here. So with this equilateral triangle grid in the background, it kind of makes it convenient to do measurements. So we can see that this triangle here is, like I said earlier, 4 units. And I just wanted to add, I found out that if for some reason this grid gets shaped the wrong way, this button here kind of recenters everything so that it's not distorted. So here we go with this triangle here, and then the article goes into taking this triangle and enlarging it by a factor of 2. So this being the first triangle here, and then we can enlarge it and then we can see, for instance, that if this is the smaller triangle and this is the larger triangle, this larger triangle's side is twice as long as the smaller triangle on all sides, and then we can start to incorporate, again, more sophisticated vocabulary and start calling this pink triangle an equilateral triangle, because using this grid we can see that each side of the triangle is 2 units long and that all 3 angles are equal. And then the next triangle, okay, so here's the next enlargement, and I kind of shifted the view to match up the grid lines because I'd like to say that I thought this was a really good opportunity to maybe make a chart with kids and talk about how our first triangle has an area of 3 units. We can count area and we can count perimeter, and then the next enlargement we can count the area for increasing by a scale factor of 2 for this triangle, and then so on with the third triangle, and without having to use a ruler or any special measuring tool on Geogebra, which I haven't figured out yet, we can just count the amount of units and play with that discovery and chart it and for any patterns that we're noticing with what happens to the area when we're increasing the scale factor of a triangle. After the exploring with triangles, the next thing that the article goes on to is exploring rectangles. And we start out with, I'm going to just see if I can reset this again. We're going to start out with this rectangle here. And if I can get it. And then the next rectangle that they show us. So here's the second triangle that they mention in the article. And if we're using the brown rectangle, I don't know if I said triangle, the brown rectangle as a unit, then this rectangle is, we can talk about how it's twice as tall, but it's the same width, and so how it's not increasing evenly. And then we can have students take these same shapes and recreate or create another triangle that looks different. Okay, so after playing around with it for a while, I realized that I cannot turn these right triangles in the direction that they are here, so I cannot create this rectangle right here. However, there are many other things that I feel like, depending on the level that kids are, you could incorporate. Using this GeoGebra activity, there's definitely reflection. Which one of these have a line of symmetry? There's rotational symmetry. And the last activity that he goes into in this article is having kids create their own puzzle of sorts and sharing it with other students. So for instance here, students could come and create this person. Okay, I had to play with it a little bit, but I think I've got it now. So I went back into Geogebra in the app and I duplicated all of these shapes and colored them gray. So I can save this in the app and have students come here and create their own picture card with the gray puzzle pieces. And I'm just going to create this one that was already in the article. Okay, once I've created my design, my picture card here with the gray tiles, then I'm going to want to lock each image. So if I click on it and here under my settings I clicked Fix Object, then it prevents anybody from being able to move these shapes. So these are all fixed and these can still be moved around theoretically. There they go. And then I'm going to come up here and save my project to Mosaic Puzzle Krissa. And so this is in the app right now. I'm going to go back to my desktop version. And I have my Mosaic puzzle here. And I open it. Then here is my puzzle card, and here are the pieces that whoever I'm sharing my puzzle with can come and use to recreate my puzzle. So in Geogebra you can create groups or classes. I think that this is my class, so if I wanted to open up geometry class, I could have my whole class save their puzzles to this geometry class here, and then share them with each other. And that's it.